So we're going to start off here. Just real quick, my background, 2-second slide. I work in TrustWave Spider Labs. I'm the ModSecurity project leader. Some other organizations I work with, and shameless plug for my upcoming book, Web Application Defender Cookbook, coming out later this year. Greg.
And my name is Greg Wroblewski, and I'm a certified ethical hacker. And I work for Microsoft. And I work at Microsoft Security Response Center, and I do different kind of security research.
All right, so real quick before we jump into ModSecurity and the new versions that we have, we just wanted to make sure everybody was on the same page as far as why do you need something like ModSecurity, right? What is it useful for? So looking at web-based vulnerabilities, that's one of the things we do in TrustWave Spider Labs. We do web assessments, pen tests, code reviews. We find vulnerabilities. So once your organization knows you have vulnerabilities in your web apps, what are you going to do about it? So then you shift to remediation. Hopefully you have access to source code, developers, and all that stuff, and you can fix it in the code. That's the way you should do it. However, we're finding there's a lot of different scenarios where, depending on the application, you maybe have some constraints, and you can't actually do that. So we actually took a survey, this was through OWASP, to figure out people that are using virtual patching, that we'll talk about here in a second. Why are you using that? And these are some different responses for, again, it depends on the application, but why you can't actually go in and fix the code. So for some reasons, it could be it's third-party outsourced code, you know, it's a black box essentially, or your developers have moved on to another project, so you actually don't have them to fix it, you'd have to reallocate them. Also, contractual language is a big problem, where, you know, the outsourced code, they were contracted to fix the vulnerability, or to write the code according to the specification. If you find security defects, that really wasn't covered. So, looking at this slide, if you're following the dots, right, you have these vulnerabilities, you can't fix them in the code, what do you think is going to happen? That means you're going to get hacked, right? So this is another project that we run at the Web Application Security Consortium, WASC, called the Web Hacking Incident Database, where we track real-world web compromises. So we're not looking at vulnerabilities, we're seeing at the end goal, which is an application did actually get hacked, and then how did they do it? So this is just a real high-level view of putting it into two different categories. Why are people hacking these applications to begin with? So on the left side, you have profit-driven hackers. You know, they're looking to make money, of course. The right side is hacktivism. So just tying those all together, I know this is the Turbo Talk view, so we're running through it quick, but obviously you got to fix these vulnerabilities somehow. So that moves into why ModSecurity. Why is it such a popular tool? So really, this is a key point that we want to bring up specifically for this talk, and also for why TrustWave and Microsoft MSRC joined together for this project. And that is virtual patching as a process. Okay, virtual patching is different. It's not quote unquote WAF, right, where you're buying an appliance or a box and it does a lot of things automatically. Virtual patching, this is a definition we have that we created from OWASP. So the key point is that you have to know about a vulnerability. That's where it starts. And then you figure out how to go back and do some remediation efforts. Okay, so ModSecurity, why is it such a great tool for this? It's been around for a decade now, right? It's well tested. Protecting millions of websites. We really don't have a lot of metrics on the actual number of installs. That's kind of hard for us to track. We can track source code downloads. And you can see there we've had over 275,000 downloads of the source code. Lots of good feature set, which comes in real handy for doing virtual patches that we'll show. And also the licensing being open source, ASL v2. All right.
So, probably you have seen why Apache is so good, and but the problem was that Apache was good, the ModSecurity was good on Apache. So, but what about the other platforms? And the most recent statistics show that Apache covers maybe about 60% of the servers and even less domains that are served out there. So what about the rest? And that's why we thought that it would be a great idea to bring ModSecurity to IIS and Nginx, because with that coverage we would be able to cover more than 90% of the internet. And there are many advantages of this approach. The one which is kind of obvious is that you could use a single protection layer in the form of ModSecurity configuration files to your entire data center or entire web farm, covering all the servers that you have. And although the way you include because the platforms are very different, so the way you include the configuration file is different. The configuration itself, the protection logic that you define, it's one and the same. So on IIS, the ModSecurity experience is slightly different than on Apache. You start with a typical Windows installer. You install it on the Windows server, and then after installation, you have to add it to your configuration file. And usually it's much bigger than on this example. Then you recycle the application pool, and then you have it running. And you see in the Windows Server event log that the ModSecurity was loaded. On Nginx, it's yet another experience because, like I said, the platforms are very different. So you have to compile ModSecurity into a library, and then Nginx does not let modules being loaded during runtime, so you have to compile your own Nginx binary with ModSecurity, and then you are ready to go. Once you add the ModSecurity configuration file in your Nginx config file, you will see in the Nginx log that the module was loaded and it's ready to go. So Ryan mentioned about why are we doing this and about the virtual patching. So we have two examples of how the virtual patching with ModSecurity can be used on IIS. And the first example is a vulnerability from December 2011, and it was a collision in hash table in ASP.NET component of the server. And with just a 1 megabyte big payload sent to the server, an attacker could make 30,000 cores busy using 1 gigabit of bandwidth. And that was leading to a serious denial of service condition. Normally this was fixed in in an emergency mode because the vulnerability was serious. But without the fix, you could using ModSecurity, you could protect yourself using different types of mitigations. And here are the 4 examples. And the ModSecurity had rules created for all 4 of them. So here I have an example of one of the rules. It's a rule that detects repetitive payload in IIS requests. It's very complicated. It would be difficult to implement in other like simple scanning tools. And when the rule is added to the configuration file and the proof of concept attack that was published is launched, the page access is blocked with access denied, and this kind of event log is logged in the Windows Server event log. So the second example is a cross-site scripting vulnerability that was patched in July. And it's a typical reflected cross-site scripting where in certain circumstances, attacker could just put a script in the sections parameter of the URL. And it was very bad. It was one of the most critical web security vulnerabilities that can be, because the attacker could run the code in the context of the user on the server and just still do everything that the user can do and more. So like steal all the documents and everything else. And that's obviously is very bad. But fortunately, there is a way. With ModSecurity, there is a way.
As opposed to the previous rules that we showed for the hash DOS, which is a little bit more non-traditional from a virtual patching perspective, if you want to take more of a traditional input validation, right, injection context, 2 different approaches, right? You have blacklisting approach, which is looking for what's bad, what should not be there. So you can do that if you know in the sections parameter, like what's the payload supposed to be in the first place? Or in this case, knowing if you're doing cross-site scripting, okay, the angle, greater than, less than, tick marks, certain the parentheses, look for those things that shouldn't be there. So in the blacklisting approach, that's what we're doing up here at the top, essentially. I don't know if this is going to work, if you can see my cursor here, right? So we want to look for that specific URL, and then we're looking only in the sections parameter. And then in this case, we're using a fast pattern match, so it's not a regular expression. It just says if you see any of those meta characters in there at all, that's a match. So you can go that route, blacklisting approach. Now, it's not quite as strong as you'd like it to be from an input validation perspective. Ideally, you do want to know what is sections parameter supposed to have. Like, is it supposed to be digits? What's it supposed to be? So that's optionally down here, the whitelisting approach. The beginning is exactly the same. You're looking in the same injection point. But then down here, if you've never really looked at ModSecurity rules or looked at them that much, here we are doing a regular expression. We do some anchoring to make sure that it only contains word characters. So alphanumeric, I think like underscore, things like that. Now the reason why this is a whitelisting approach is with the ModSecurity syntax, if you put the exclamation point at the beginning, that inverts the logic. So what you want to do in regular expression is define what should have been there in the code in the first place, right? What the developer should have been doing. And in this case, you just say if it's not this, that's a problem. Okay. So typical event log now. So you can see all that stuff funnels there, so you can get all your events and see which stuff is triggered. Okay, so ModSecurity 2.7.0. We have release candidate version 2 out right now, so we've been testing certain things with it. In ModSecurity, like the core itself, but then also with these new versions for IIS and Nginx. So 2.7.0 is the first multi-platform supported version that we have. You can go download it today. If you go out, it's currently hosted on our SourceForge repository. So the top URL is where you get to the regular ModSecurity source code. If you're only an IIS user and you just want to grab the MSI and install it, got the link down there at the bottom. You can do that. Turn it back to Greg.
And from the Microsoft perspective, we expect to use ModSecurity in our response process. As you can imagine, the availability of ModSecurity for IIS give us possibility to publish rules that would let our customers be protected from any vulnerabilities that are being either disclosed to us or disclosed publicly. And we also expect that the community work will start on creating the rules that will be specific to ASP, ASP.NET, and IIS environment. So, summarizing, we have the ModSecurity has entered a new stage. We have it available on 3 platforms. We encourage you to learn more about this, about the effort. You can even look at the source code. It's right now it's in the experimental branch on the SourceForge, and we will publish blogs about the release tomorrow. And there are a number of people who contributed to the effort. So you could find some of those people. Actually, most of those people, you can find them here at the Black Hat this year. And we have one more thing coming.
All right, yeah. So because this was a turbo talk, obviously we couldn't do all of the demonstrations that we would have liked to. Fortunately, we did get some slots in Arsenal. So if you know where the Arsenal area is, at 3:30 today, we're going to be there for an hour, and also tomorrow at 10:15. So if you do want to come by, see ModSecurity as a whole, or want to see some of these different versions, stop by, Q&A, see some more demos. And I think that's it. So thank you.
Well, good afternoon. Thank you for coming. We are Matias, Katz, and Maximiliano Soler. We are talking about HTExploit and how to bypass the Htaccess restrictions. Come on. Okay. Matias Katz. See if you want to introduce yourself. Go ahead. Okay. Matias Katz is a penetration testing, has a company named MKit Argentina. He specializes in web application security, also do penetration testing. Me, Maximiliano Soler, I live in Buenos Aires. I work for a bank as security analyst. Okay, basic concept. This is for introduce everything and everyone to the basic concept. Htaccess is hypertext access, and basically is a configuration file to with directives that is to use to configure H directory or files. For example, you can use the Htaccess to redirection, URL redirection, and directory listing protection, URL rewriting, and authorization authentication. This is the main of this talk. Okay, why attack this type of protected directory? The common things to get are backups files, configurations, and update versions, new developments, because sometimes we have developers or sysadmin that put all your backups in this protect the directories. The tool is named HTExploit, and the meaning is hypertext access exploit. It's a tool written in Python that exploit a weakness in the way that Htaccess are configuration. For example, you will be able with this tool to bypass this authentication process. The main features of this tool is free and open source. If you want, you can collaborate. It's user friendly, flexible, has a lot of modelizing, is integrating with major tools. In the next version, we'll be integrating with Nmap, ModSecurity, and has a funny report. We built it. This is an old weakness. It's not now. It's not new. Sorry. We haven't not having found currently exploited by other tools. A lot of websites recommending how to implement Htaccess vulnerable and from fun and profit. What is not Htaccess? It's not a one-click punish tool. It's not a replacement for other web hacking tools, and it's not completely integrating with other tools. Okay, this is the common configuration for protect directory. Have you ever seen this type of configuration? Yeah? Okay. At the first line, this is the HTTP pass WT. Out name, authentication basic. This will be others if you want, could be, for example, dishes. This is the directive limit with get and post. Go ahead. Viene la demo. Sí. Okay, we have found a lot of universities recommend this type of configuration, but this type of configuration are vulnerable or has a weakness. Demo.
Okay, hi. We've been in Arsenal at 10 a.m. and people have come around our booth and asked us to show them the demo, and we have presented them with this Htaccess configuration, and we have been asking them if they would upload this Htaccess to their production servers. About 95% of the people that saw this configuration said yes. This is very typical configuration for Htaccess because it limits the methods available for usage of the directory, just for get and post, so that you won't be able to perform an options or a trace or whatever. That's a very common, very typical, and very chosen configuration for Htaccess. Some people said, okay, maybe I wouldn't use basic, I would use digest. Somebody said, I won't use HTPass WD because it's too standard, I would personalize the file, that's okay. Some said they would use TLS, that's okay too. That doesn't matter for this exploit. Even if you use digest, even if you change the password file, even if you use TLS, yeah, even if you use digest, even if it's only one valid user instead of any valid user, you would still be vulnerable. So, many of these universities and also hosting providers and cloud providers and companies and our customers and whatever, they have all recommended this type of Htaccess, this exact type of Htaccess. And this is a vulnerable Htaccess configuration. So, what struck us down was that about 95% of the websites available online were recommending users to use this kind of Htaccess. So I would encourage you to go check your servers if you're vulnerable or not after seeing this demo, because a high percentage of you will be vulnerable. So let's see the tool. I have a server here. It has a private directory which is protected. Of course, if I try to access it, it would go to the demo, of course. Okay, it asks for password. This site is protected by an Htaccess with a vulnerable one, so we can exploit it. So, what the tool does is quite simple.
Right.
There it is. The tool is quite simple. It's written in Python, it's open source, we'll be publishing open source. It has many modules to charge. You can use the detect module, which is the standards. That's what we're going to use. You can redirect the output to whatever you want. But the main parameter that you need to express is the URL. The URL is the only one required. That's the URL that you want to exploit. So in this case, we want to exploit the server that I just showed you. So we're going to use private, and let's set it to verbose mode. So what the tool will do is try to download index.php inside the same private directory. So that's private/index.php. So it could download it. What the tool is showing is that the directory is exploitable. So what the tool can do now is perform what it's called a full scan. The full scan will take a word list that is provided with our tool, but you can use your own. And bear in mind, this is not a dictionary attack on the passwords. This is not a password cracking tool. The word list is just for files. What we have put here in the word list is the typical default pages that are available in WordPress, Joomla, and whatever. And that's what we're relying on. You can use your own word list, and if you have a word list of 2,000 different forms, you can use it. But it's not a password cracking tool. Several people have told me that during Arsenal. It's not that. You're bypassing the authentication. So if we do that with the full list, and it starts the full scan, it will try to download each of the files in the word list. So we'll try to download, and at the end, it would say that 52 files were downloaded out of 750 with a 60% success rate. That means that 52 files from the server, from the protected directory server, have been downloaded to our computer. And now it's locally on our server or on our computer. But the main functionality of this tool is the link scanner module. The link scanner module will try to download all the files and then read inside of them and search for links. And each time it checks for a link, it tries to download that site also from the server. So if I run the link detect scan module, I will run it. And for each one of them, it will show all of the links found. For instance, in article.php, we have found 23 links, articles.php 11, index.php 11, and that's it. And after removing duplicates, we find 23 new links found. That's without knowing the internal structure of the site. That's without using the word list. The word list was just the first step of the process. Now the tool is reading from inside the server, from inside the directory, and checking for links and downloading those links. So now that the 23 links were found, you can run a new thread of HTExploit with those new files and download those also by growing horizontally and trying to make the final report bigger. So we're going to download those files, and it check index.php has been downloaded, blah, 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 external links are skipped, blah, 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 and there were 7 new files downloaded out of 20, and now you can rerun the link detect scan on this new result. This is a recursive procedure that would end only when you have successfully downloaded each and every file on the server. And it would recursively try again and download and link detect and download and link detect until it's finished. So we're going to do yes. He's going to download, and the tool found 66 new links. So we're going to run a new HTExploit thread to download those. And now the tool downloaded 59 more files, and now we're going to run a link detect scan. Now it found 619 new links. This enables us to grow the size of the report, the final report. We're going to run a new HTExploit. Now it full scan completed. No new files were downloaded. That means that we have successfully sucked everything from the server, and we can go home happy. So 115 total files after 4 iterations, and the final report is right here. So if you open up that, the report directory, and we have a nice HTML report that lists all the files found on the server. Those are the 114 files. Can't say what it says, 115, and it shows 114, maybe a small bug. But if you access these files, you can access the actual information. Chocolate Dalmatian. And we access that, and that's it. So what are we looking at right here? The vulnerability in Apache only allows us to download PHP files. It won't download HTML. It won't download JPEG. It won't download style sheets. It only will download PHP files. So you won't get any fancy output. But you will get the data, which is the most important one, the most important part. We now have the entire content of the server that, if we access it correctly, it's a nice coffee racks site for maybe a local business or something, and articles. You can all the articles, and then there are all the types of coffee. And this is the same information, blackeye.php. We're going to look for blackeye.php. And that's exactly the same, just without the graphics and the fonts and the styles and the whatever. But the data is on our computer right here. For each downloaded file, we get a local copy with all the information we need, with a nice full report to show to our customers or whatever. Well, that's it. That's the demo. That's the demo. That's the demo. No, okay.
Okay. Do you hear me? Yeah? Okay. The weakness. This is the most important part. The problem resides how to the HTTP requests are being limited. The following statement, for example, is limit get post, require valid user and limit. This indicates that only applies to get and post methods. What happens if we generate another non-standard method? For example, potato. Okay. When PHP receives the non-standard method, it processes it like a get, downloading the request file. Solutions?
The thing is that Apache can handle the methods that you have. The method that you have disabled, Apache can handle them. So, but if you use a method that is not common to Apache, Apache will pass it along and send it to PHP and say, hey, PHP, maybe you know how to deal with this. That's how you bypass Apache. And then when PHP gets the request, if PHP gets a request with a method that it doesn't know, it treats it like a get. So you bypass the require valid user because you're not using neither get nor post. So it doesn't require valid user for those limits. So Apache sends it along directly. And then when PHP gets it, it treats it like a get. And you get the files. Go.
Possible solutions: improve the Htaccess configuration, Apache module experimental, and the PHP code. Okay. From the Htaccess configuration, you will be used, for example, the limit get and post. Add also the limit accept get and post the name for hour. This says that the restriction access control to all the HTTP methods except to all ones specific above.
With the limit accept, you are also disabling anything that is not get post, because if it is get and or post, you would require a valid user. But if it's not neither get nor post, it would deny all, and that's it. That's how you can treat it from the Htaccess itself.
Apache mod allow methods. This is an experimental mode. Basically, it restricts only to the HTTP methods that can be used on the server. It's important to say that it's case sensitive and was written to replace the current implementation of a limit and limit accept, but it's experimental. If you are developer, in your PHP code, you will check, for example, the PHP out user, and then you must to check, for example, server request method and see if use get or post, you will be only accept the request. If you have another one, you will say you will show an error message.
That is to prevent the default fallback from PHP. You can process it through the filters, and if PHP detects it's not neither get nor post, it would disallow the connection.
Okay, and words is not enough to declare the traditional HTTP method. You must to restrict the access to those methods ignored or unwanted. You must to do the perform necessary security checks.
Okay, what is our roadmap? Of course, the tool has been written in Python, so it's open source. The tool has already been published. Now we'll give you the link so you can download it. It's also going to be run on, of course, anything that runs Python, Windows, Mac, Linux, whatever. And it's going to be in the next versions of Matrix and Samurai. You will be able to find the tool there. And what is the roadmap? Our next release is going to be the 1.0, which includes the link scanner that we have shown during the demo, and it will also include the remote file inclusion, local file inclusion, and SQL injection. That would be next month on our site. Now you can download the version that 0.7. It's a beta version that works perfectly fine. You can download it now and try it on. And we're working to integrate the tool with either Metasploit for gel injection and Nmap for detection of other directories, other servers, other web services in other ports, and doing a more horizontal growth of the tool. Right now, from the root, for each directory, it does a subdirectory and so on and so forth for each and every file of the directory. And with the new integrations on the newest version, we will be able to cross it with an Nmap result and get different web services from the same IP address, and also robots.txt detection. So it will maybe look more like a Pwnage tool. So we don't want that, but we're working hard on not making it look like a Pwnage tool. But we will try to integrate it with Nmap and Metasploit for gel injection. But we already have developed these modules and they're working, but the code is still a little bit dirty and patchy, so we won't publish it for the next month. But you can now download the version 0.7 beta from this URL, mkit.com.ar/labs/HTExploit. You can download it right now. It's published before our talk. So these are the references from all the research that led to this tool. We haven't found any tool that did this before our investigation, so we decided to make a new one. So if you find one, maybe you can email us with that tool. Maybe we can cross-reference and see how to improve our tool. Or we can stop our investigation altogether because we don't want to reinvent the wheel. But we haven't found one. So these are all the references for the investigation that led to our tool. So, questions? Any questions? Yeah?
Try like any other, like outside of PHP, like this ASP or JSP or any other dynamic runner like responding to get?
Unfortunately, it doesn't work. The fallback that allows you to get the files, it's a flaw in how PHP is developed. But it's not a fault that has a CVE that needs a patch. You won't see a patch. Actually, this vulnerability is very old. It's old. And there hasn't been a patch. Apache, you can upgrade it to the newest version. PHP also, it's not a patch requiring vulnerability. It's a weakness in configuration. It's a misconfiguration. If you go and add limit accept to your Htaccess, that's it. So anything that uses Htaccess with PHP is vulnerable. Not IIS, but everything that uses Htaccess, if you have PHP behind. Yes?
Is this specific to specific OS like implementation of PHP, or is it all PHP?
No, it's OS independent. If you install Apache on a Windows server, it will exploit it. Yeah. We're good? We're good? Okay. Thank you very much.
Thank you.
Woohoo, all right. And everyone's eager to go on the next talk, so we'll do this fast, keep everything on time. So we're going to talk about lib injection today. And if you're looking to follow along, you can go to this website. The slides are somewhere down there, and you can check it out. Okay, who am I? I'm one of the directors of engineering at Etsy. Etsy's an online marketplace. My specialty is sort of enterprise-related features, fraud, security, email infrastructure, fun. So what I'm going to talk about is a C library, which is actually easy to port to other languages. And my previous sort of embedded C library is actually used in just about every ad server in the world. It's used in the Chrome browser. It's also open source, so you can check that out as well. But just to give you some background on development. Okay, so next 14 minutes, we're going to go through like why detecting SQL injection is hard, and why certain other algorithms and methods don't work very well. We're going to talk about the algorithm that is sort of newly developed and produced here, and the results, and then some next steps on how to move forward with it and use it in your application or to develop new tools from it. All right, so it actually turns out detecting SQL injection from user input is a hard problem. And the reason is, it's really easy to get started with regular expressions. It's like, hey, it's just a union all thing. And I know at least 2 open source web firewalls use this, and seen from the exploits done and the workarounds done, it looks like a number of the commercial ones do it as well. The faults sort of indicate they're not really They're too trivial that they must be regular expressions. So SQL is also huge. If you ever sort of looked at it, the actual spec from 92, which you can sort of download, it's 600 pages of plain text just describing how it works. The 2003 spec, just the BNF form, is 128 pages. No one does it exact, and everyone has like extensions and things associated with it. It's a really big language. It's also Turing complete, so basically you can go write web servers just using SQL and things like that. Just using regular expressions to capture that richness of a language is going to be tough. And it's actually a lot more complicated than you think. Postgres has got recursive or nested commenting rules. A single number has so many different forms, you can't use a single regular expression for it. It's really loosely typed. You know, there's conversions going on all over the place. And for strings, you think you know, but you have no idea. The exceptions are incredible, and I'm going to be talking a lot more of this at DEF CON at 420 on Friday. So if you're interested in more sort of analysis of sort of new exploits, come check it out. Anyway, so what happens is a lot of the web application firewalls have sort of ended up using what I call regular expression soup. This is actually part of the regular expressions used in PHP IDS. ModSecurity has some similar sort of rules. It's impossible to debug and test against. And in fact, in Black Hat in 2005, Hansen and Patterson had this great article or theorem actually, it said that regular expressions, no matter what you do, it's going to miss something, and something that you don't want is going to be flagged as a false positive. And it's a pretty interesting article. It's a little technical, but it's definitely worth checking out. And existing web application firewalls, just going back to the regex soup, some of these, if I had a pointer, I could point out some. By inspection, if you stare at it long enough, you see bugs, or things that are hardwired. Oh, it can't be more than 10 characters. You know, it can't be followed by a certain character, and it turns out they can. So I didn't see a whole lot of testing, either on the forward case or in the negative case for false positives. I don't know what it's detecting and not detecting. And that's just for open source. Closed source, no one knows what it does. And nor do they have any responsibility to disclose what they're detecting or not detecting. Okay, so can we do better? Hence the talk. Here we are. So the main thing is, when SQL injection occurs, it's from user input, from the query string, from post, from a cookie, whatever it is, it's getting injected or dropped in place in a SQL query. So a SQL injection tag is really like, could the input actually be parsed as a SQL snippet? And the thing is, the whole thing has to, for a SQL injection to work, the entire query has to be valid SQL. So it really, this hard question sort of boils down to is, could the user input be the start of a SQL sort of snippet? You don't necessarily need to look at the whole thing. And there's only just a few ways you can really do SQL injection. If you got some other new ways, I'd love to hear it. It's dropped in as is. It's dropped in expecting it to be in part of a single quoted string or as a double quoted string, depending if you're MySQL or not. You could possibly put things in a comment, but we can't fix everyone. Okay, so then turns into a slightly different problem is, how do you detect if user input is SQL, good input, what is it? So like my phone number, is that my phone number an arithmetic expression? Is my Twitter handle, Twitter handle, or is it actually a SQL variable? And so trying to disambiguate these things turns out to be a little bit of a hard problem. And I looked at some existing SQL parsers, and they only really parse their particular flavor of SQL. They're not really designed to handle partial bits, hard to extend, and they're very worried about correctness. I'm not as worried about correctness. So I wrote my own, which sounds crazy, but turns out to be pretty straightforward and not too bad if you don't actually need it to run SQL. So what this thing does, it converts input into a stream of tokens. There's a master list of keywords and functions, which is sort of combined against all the major databases. There's only a few hundred of them. It's not completely intractable. And handles all sort of the comments, strings, literals, and all the weird cases and things like that. And we'll get to some examples in just a second. Maybe right here. So here's an example of something that sort of got pooped out of SQL map. And it sort of turns this whole thing into sort of a stream of tokens, as you can see. In this case, it checked to see that, it's the first part's in a single quoted string context. And then from there, it sort of kept going onward. Okay, so anyway, you end up with a stream of tokens. And there's a bunch of them. There's maybe about 12, 16 of them. These are all the different type of things that sort of come by. And this has been sort of a refined list over many iterations of sort of the algorithm based on real attacks and benign input. So you get this whole stream of tokens coming out. Then there's another step which disambiguates, specializes, and merges tokens together. So like is not turns into a single operator. Natural join turns into a single operator. Is the operator unary or is it an arithmetic operator? And the last one's slightly interesting. If you see COS, the cosine function, I'm an old math guy, so that's sort of what happens. I use math examples. Cosine followed by a number. Well, cosine is a function, but if it's not followed by a parenthesis, it's actually not a function. It's just some bare word floating around in there. So it goes through this whole step and sort of disambiguates stuff, merges tokens, specializes, merges strings together, does all the stuff it needs to do. And then it does one last step, which is really designed to reduce false positives. And that if it sees like a bunch of arithmetic operations together, it just merges them all together. My phone number just returns into 1. We don't actually care what the value is because SQL injection doesn't care what the value is. It's just there's a number there. Same thing with multiple nested parentheses, just get rid of them. It's not important for the SQL injection part. So, what's interesting is so far, it knows a little bit about SQL, but right now I've gotten to the point where it doesn't know anything about SQL injection. It's just parsing SQL. And that's great because you can actually fully test this. You can go through the whole thing, pound it with different inputs, and you know the answer to the result. So it's actually a good way of like writing tests and some other stuff. It doesn't know anything about SQLi, which is great because it's always evolving. People are coming up with new tricks. So here's another example of another example of something that came out of a SQL map, and it turns it into sort of a stream of tokens. And in this case, you can see the example. It turns into a string, a union operator, keyword, a number, a comma, and it can keep going on from there. And so what I did is, let's now generate this stream of tokens on real-world data. That's $5, Zane. So from this, can we actually distinguish what's benign and what's SQLi? And again, so what I did is I grabbed every SQL map type of thing there, mole, SQL Ninja, all sorts of different things, made a fake web server, had them pound my fake site just to capture all their output. I got about 32,000 samples doing this. Certainly I could squeeze a lot more data from them. It'd be a great project if someone's interested to help out. And then I trained on real input. I grabbed Etsy's logs. They were nice enough to let me use them. Hundreds of millions of user inputs. Etsy, if you're not familiar with it, is actually a fairly large site. It's a top 50 website in the United States. It's been around 6 years, which means the application's pretty big. Lots of different ways of processing and parsing user input. And we have a full text search where people enter all sorts of crazy stuff they're looking for. It's great real world stuff. So, ran this through, looked at SQLi, looked at benign inputs. How much input do I need to look at in order to see if it's benign or SQLi? And the magic answer is 5. Once the tokenizer gets 5 SQL tokens, it can distinguish between if it's SQLi or if it's just benign input. That's really interesting compared to a regular expression, which is going to be parsing the entire input. You have a 10 meg post input, it's going to be parsing 10 megs of data. This, as soon as it hits 5 tokens, done. So that was a surprising result. And here's sort of a sample of them. Out of the million or so, using my sort of methodology of possible fingerprints, only 480 are actually SQLi. It's possible I might add some more tokens later to help reduce false positives, but that's it. That is your template for SQLi as we know it. The title of the talk was using it for offense and defense. This is a great way of mining to see things I'm missing. This is all based on real world data. There's lots of things you can actually look at and go, hey, you know what? People use the number there, but we can actually throw in a variable instead. So I'm sure it's missing things, and it'd be a great little project to find areas it's missing. Anyway, one other thing about this I'm just going to mention is because it's matching token types, it doesn't really matter what the function is, what the string is, if it's a number, it's generic. So if someone does some crazy blind arithmetic thing that uses some new math operators to sort of work around things, it doesn't matter because all I see is a function. It's a keyword, it's a function. I'm not actually looking at the value of the SQL itself. So, the library itself, I did it in C only because I wanted to see how fast it could run, and also I really am curious on getting this embedded in some other systems. I'm really going to be excited to work with hopefully ModSecurity to make it a Lua call out for them. Logic's under 100,000 lines of code. It's not very big. There's maybe a few K of data associated with it. There's no memory allocation, fixed stack usage, no threads, and I'm pretty sure we can make this go 2x faster if we needed to. More so, this is sort of the basic thing for C people. It's that simple. You make your variable, have your user input, pass it in, it will tell you. Metadata on the function, including the list of tokens it found and what matched, is actually in the structure sFilter up top. Might change the names, but it's really quite simple to use. Test cases, all the test cases, 32,000 inputs I'm using, all my false positive I use in developing this. They're all included. Code coverage reports, the works. I started out originally programming in Python. It's not quite up to date to the main algorithm, but I will get to it. And we're working on it, and it runs quite fast, actually. If you're familiar with PyPy, you're doing maybe 50,000 a second. It's pretty decent. Here's another way you could do that. If you're not really interested in detecting SQLi, or maybe you have an existing set of regular expressions, you can actually use this to make it a SQL normalizer. Strip out all the quotes, lowercase, just make everything normalized. Various numbers just converted to 1, all these different things. It actually will make existing regular expression detectors work better. Great for fuzzers. Again, those templates are actually what you can use to generate valid SQL injection attempts from all those different fingerprints. And it's available now. Website's got not only these set of slides, the sources on GitHub, the links over there, BSD license. I might move that to MIT. BSD is only there to see who uses it. And there's lots of interesting stuff to work on here. I'm going really fast because it's only 15 minutes, so if you're interested, come on by. I really am looking for someone who's more familiar with Oracle and Microsoft and porting to some other languages, which really is not too bad to do. And as I mentioned, Friday, if you want to see like all the variations of SQL and things that you never thought possible, this Friday, 4:20, I didn't make this up, at the Rio. And here we go. Thank you very much for sticking around.